Okay, I think we can start now. So this guest of ours has been in the development field for quite some time, but I think it's best if he be the one sharing his background with you. Uh, his name is April Pineda. Hi, April. How are you doing?
Hi, John. Great, thank you. So I've been in the
That's good.
industry as a full stack developer right from the start when I applied. It's been about 3 years ago. So I've been in the industry for more than 3 years. But before that, I also did some freelancing work while I was a student.
Okay, all right. That's a good background. So I think April has something in store for us. The thing that we'll be talking about is spaghetti code, how to do clean codes. So April would be digging into specifics and would be sharing something over. If you have any questions about the role, you can just paste it in the comments, and then we're gonna try to answer it as much as possible after his presentation. And so yeah, keep the questions going. Listen attentively, and hopefully can pick something up here that would be really be useful to kick off your career or for you to use in your future projects or your current. But yeah, take the floor, April. Thank you.
Yep. So I have a presentation right here that I'm going to share my screen so you guys can see well. So I'm going to talk about spaghetti code and how to avoid it, specifically things like writing code, Latin clean code. So we will try to identify what it really is, what it means, and why it happens and how it happens. We will try to identify its nature. So learning how to code is one thing, but learning how to write clean code is a completely different discipline on itself that requires a completely different mindset that somehow can only be acquired through some years of experience. You only see people talking about clean code when they start to gain experience past 3 years or even 4 years. But before that, you'll see them just writing code. So writing code is quite easy. Actually, anyone can understand it and anyone can learn how to write code, especially these days when you can just Google search whatever you want to learn. But writing clean code, how to write clean code, is something that requires a very deep expertise in the art of software engineering. That's what we will try to understand in this presentation. So this is just a guide. This is not a prescription to solve whatever spaghetti code problem you may have currently, but this guide will enable you, equip you with the right knowledge to maybe identify the solution for your problem. So what is spaghetti code? Spaghetti code stems from the fact that it is actually harder to read than to write. This is true not just for software engineering, but this is true especially for software engineering. We are writing almost non-human readable things. Uh, you could barely make up some of the things that we write unless you are a software engineer. But we do use some common words like if, else, etc. to allow us to understand it better. But writing, say, a poem is also hard. But reading a poem is even harder because reading requires that you focus 100% of the attention so that you're able to understand what the poem is saying. And the same thing is true for reading code. So that's the primary root cause of that spaghetti code. The problem is, how do you allow anyone to read any code that you write? So writing a code is basically like writing a movie script. It follows a format and structure in a form that other writers will understand. So I have in here an example of a script. So this script is the Harry Potter script. So I'm just using it as an example for educational purposes. As you can see, this script is actually well written. You can see it's properly spaced and it has headings. It does have these indicators here. It has these headings. It has indication that ext here means that this is happening on an exterior site. And there is setting a place for the people who set up the place to understand where they should shoot. And there's also the INT, which means interior, which means inside of a particular building. So it's very clear to understand, and even people who don't write script will actually be able to understand this. And it allows other script writers to collaborate together in a way that that one script writer doesn't actually need to read like a thousands of pages of scripts. If he just needs to modify a particular scene, he doesn't need to go through all of the scripts. He just have to go through that particular scene and read that scene and modify that scene. So the same thing goes for software engineering. If say you just need to write a code to implement a feature, you shouldn't need to go through all of the code base, thousands of the files and thousands of lines of codes just to do that, implement that particular feature that you need. Well-written code doesn't require you to do that just to achieve something that you need to do. And creating software as a tool is almost like creating a book. A book also follows a format and structures. So I think everyone's well aware of what the books, parts of the books are. So here's just some example of some parts of the books. So you have the front matter, there's also the table of contents, and of course there's also all the way back to the back matter that contains the appendix and the glossary and those kind of things. So it follows a format that allows any reader, a beginner or expert, to understand the book, to read the book and absorb the knowledge being sent by the book. So the same thing goes for software engineering. When you're writing software, you actually think that you're not writing the software for yourself. You're writing the software for someone else. So let's understand the nature of the problem. And I found that this is best explained through an analogy. And the analogy that I would try to use to explain this is an illness called cancer. So the spaghetti code is basically like cancer. If you try to understand cancer, what makes it really, really strong and really, really dangerous is that it has the ability to become invisible. It just sits there unnoticed, unseen. You can't detect it, you can't see it, you can't even look for it, but it's there. You don't see it, you don't feel anything about it, you don't feel any symptoms, you don't feel any bad things going on in your body, but it's there. And while it's invisible, it's gaining strength and it's exponentially growing until it reaches a time when it's so big, it becomes so obvious, and then that's the only time you'll be able to see it and detect it. And then by that time, it's already too late because the cancer may have already weakened your entire immune system and may have also damaged the rest of your healthy organs. The same is true for spaghetti code. At first, it's there. It's just there. And you don't see it. You don't feel it. You don't recognize it. It's almost completely invisible to all the developers who's working on the product. But then it exponentially grows and it continues to grow until it reaches the time that the entire code base has been spaghettified. That the entire code base has been written in a spaghetti code manner. And that time, it's already too late. The spaghettified code, the spaghettification code has become an intricate part of the code that rewriting the whole code means going down to the root and refactoring the entire code base from there, which requires a lot of effort to do. So um, the only time when you're actually able to feel this problem is when it's kind of too late, when it's like 4 years or 3 years in the future. And maybe developers would say, well, that's 2 years in the future, so that's you don't really mind about that. We're just gonna deal with it when the time comes. But the problem is when that time comes, it's already too late. That it's almost impossible to fix. And I've seen some companies who went through this problem, and the solution that they always come to is just scrapping the whole code and creating from scratch again, and then this time they try to do it better. So let's talk about the symptoms of the problem. Like any other disease, these also have symptoms. Spaghetti code will have symptoms along the way that's telling you, hey, there's a problem. Look at the problem and try to solve it. So one of the symptoms is having a code base that ranges from hard to almost impossible to maintain. And I'm pretty sure some of the developers who've been in the industry for more than 5 years have experienced that when you're asked to maintain a particular product, one of the things that you have to do is actually read the code. But a spaghettified code base is very hard to understand and very hard to code that maintaining it, implementing new features, fixing bugs, and removing some existing features may actually be a challenging thing to do and may even produce even more problems than it solves. And another symptom is that tasks will become harder and will take longer than usual because as everyone just struggles to understand this spaghettified code that they could barely make up, they will still try to implement that feature. And they will try their best to implement that feature and they will try to read as much as they can and understand as much as they can about the code base. But again, it's a very spaghettified code base, and so it takes them, say, 4 hours instead of just 2 hours because of the spaghettified code base that you may have, or even longer than that. Sometimes people would even say, don't touch that code because it works. And touching that code may break other codes because, again, it's a spaghettified code, and because you don't understand that code, you can't really touch it. then workarounds become more and more common because as you refuse to touch existing codes, you will find yourself creating even more code, which may on its own is actually which may on its own is actually spaghetti code as well, because well the fundamentals, the basis, the structure or the foundation of the code base is already spaghettified. That any feature you add to it may have been also spaghettified as well. And this is not the problem with the developers. This is sometimes the problem with the environment itself. If you put a good developer in the wrong environment, in a very bad environment, that good developer will actually underperform. And that good developer will not be able to reach his full potential. And he just would probably quit along the way and find a different environment that suits him well. So this is not a problem with the developer, which at this time, as we go on with the presentation, you'll find where the problem really is. And ultimately, the ultimate cost of this problem is the onboarding. It becomes hard to even impossible to onboard newly hired developers to maintain the product that you have, the code base that you have. Because again, they will need to go through the code, they need to read it and understand it. But a spaghettified code by its nature is very hard to understand, to even impossible to understand because its structure is just vague and not clear. So onboarding becomes so hard. So cure. Is there any cure to this problem? Well, there might not be any cure, depending on how bad your problem is. It's like if you're stage 4 or stage 5, then the only solution for you is probably to stop the whole thing and just quit from scratch again. This time you have to do it better. But if it's still manageable in a way, you can still try to refactor some codes, but refactoring is actually harder than like writing codes. So how do you eradicate spaghetti code? Or can you even eradicate spaghetti code? Well, the answer is you can't. You can't remove spaghetti code completely from any code base. Any code base, doesn't matter if it's from a giant tech company or someone written by a very highly senior developer, will still have some form of spaghetti code in it. The key is not to remove it. The key is not to eradicate spaghetti code from the app because you can't. The key is just put it under control by minimizing it. Ideally, your code base should just have like 5% to even less spaghetti code in it. The rest should be very well structured and very well defined. So how do we minimize spaghetti code? Well, we can minimize spaghetti code by the work of a superhero we call coding standards. So there are some coding standards that you can implement right from the start, but ultimately you will have to do the research to fundamentally build that coding standard that you like to implement in your project and everyone will follow. But coding standards is the key to controlling and minimizing the spaghetti code problem. So one of the things that you can do is this. You can do it right the first time. That's the first coding standard you should have. Do it right the first time. Don't make the same mistake as Thor did. Go for the head. Like chop that off. And do it right the first time. Don't even leave any room for mistakes. Again, do it right the first time. Because the moment you try to make an excuse, then you just give way for problems to exist and that problems may exponentially grow. The next thing is avoid excuses. Yes, you should avoid excuses. What I found is that developers actually don't they don't necessarily write ugly code or spaghetti code because they can't write clean code. They can write clean code. The problem is the environment encourages them to make excuses. So the developer will just be lazy and just say, yeah, I'm just gonna write as long as it works. And everybody will have that mindset that as long as it works and everybody's just writing their whole thing, their own thing and just doing it as much as they please, which is contributing to the overall growth of the spaghetti problem that you have on your code. And one of the common excuses that I've heard from most developers, and I think all of you are also very much familiar with this, is this. I will refactor it later. And we all know that the later doesn't really happen. Like, right? Like you'll say, I'm just gonna write this down. Then as long as it works, I'm gonna write this the ugly way, and then I'm gonna come back and refactor it later. But then 2 years later, 2 years later, you look at the board and you'll see one ticket there that says, I should refactor this code. And you'll be like, huh, there's this ticket from 3 years ago. Man, I should have refactored that spaghetti code I've written 3 years ago. How come I didn't? Well, because there's this stream of things that you need to do, streams of bugs to fix, bugs to investigate, or features to add, features to change, because the client change his mind, and those kind of things. And those things are very much more important than refactoring a code. So the solution is to not give way to refactoring code. You shouldn't even find yourself needing to refactoring code. If you find yourself needing to refactoring code, then that means you just wrote an ugly code and an insufficient code. I think the only reason why you want to refactor a code is when you're refactoring it for the sake of performance increase. Another thing that you can follow is the team itself, the team lead and the managers should promote clean coding. They themselves should promote clean coding. If they're like the kind of people who says, I don't care, just do whatever it is, just do it the way you want to do it. Everyone just runs around doing whatever they want until inevitably it becomes a spaghettified code base, and only one person, possibly that person who's full time in it, could understand it, or even that one person won't be able to understand it fully. Why? Because the managers doesn't promote clean coding. So the managers themselves should promote clean coding. It should start from the top rather than the bottom. So set up formatting tools like ESLint and Prettier. When you don't use ESLint and Prettiers are actually good things to like enforce coding standards in your environment. When you don't use these things, you give way for developers to just neglect um, following the rules and following the coding standards. Another thing that you can add in here is PRs or PR reviews, pull request reviews. This is when I'm making a pull request to the Git branch, and then I'm asking a peer to review my code. And the point of reviewing the code is not actually to find the bugs in it. That's just sort of the byproduct, but it's actually to ensure that everybody can read it. That this guy verified that, hey, I'm following the conventions, I'm following all the coding standards. And also the code should describe itself to the reader. When you're writing a code, you should always think about how other people will read it and how much time will other people take to understand it. The code should describe itself to the reader. If you're finding yourself needing to write paragraphs after paragraphs of um, comments on your codes, like paragraph comments every statement, every switch case, every if else, every functions, you write this paragraphs of the comments explaining it, what it's doing, then that means maybe the code is not describing itself, not clear enough to the user. Because if the code is actually clear, you'll find yourself writing comments less and less. And the last thing is don't compete with your teammates. So apply clean code mindset to your project. Okay, so clean code is like a mindset. It's not really exactly a skill. It's not really exactly something that you obtain from school or from training. It's more like something that you obtain through experience and through practice. And it's a mindset that everyone should apply in the team, including the managers. And everyone should subject themselves to this mindset, and everyone should follow this mindset. And the managers should enforce this mindset on the project. And once you apply this clean code mindset on your project, you'll find that your project will actually become easier and easier to manage to a point that you probably don't even need to spend a lot of time in there as a manager. The team just becomes sort of autonomous on themselves and just completely self-managing. Uh, but yeah, apply this to your project. And if symptoms persist, consult your doctor. So let's go on some hands-on examples that I have prepared for you guys. So I've tried to write this code as badly as I possibly can, but unfortunately, once you have actually developed the habit of writing clean code, you'll actually it will be actually hard for you to write ugly code because your brain is just automatically doing it for you. It became a habit that you don't need to even think about it. So I tried to write this in the most ugly way that I can think of, and this is the ugliest that I could think of. As you can see, I'm not following any conventions here. A code is, yeah, it's completely under. You can actually understand this code. You can take some like 10, 15 minutes to understand this code if you're a newbie. And if you're a completely expert, probably take you 5 minutes to understand this code and understand what it's doing. But this is a very, very short code. So imagine having this kind of code, but in terms of hundreds of files and thousands of lines. Can you imagine working with that kind of code base and trying to understand it? Right now, you're probably wondering what this is doing. And you'll see what this is doing just the moment when you try to refactor it into this. So this is what that code is actually doing. Yes, it's kind of longer compared to the previous one. It's like 23 lines, but this one is 40 lines. But if you look closely, it's actually very readable that you don't even need to dig very, very deeply into the code. Like if you just need to change something, say your project manager, there's this task that says increase the length of the array from 100 or increase the length of the array into 1000, then you know exactly where to go because you can see the the names. The names are already describing themselves to you. The code is describing itself to you. It's trying to convey the message, the thing that it's doing. It's like waving at your face saying, I'm doing this. It's basically that. So let's take a look at what happened on that code that we just refactored. So first is, of course, concise naming of variable, constants, functions, etc. And I use the term concise. So concise actually means to be clear, to be short, direct to the point, and not to be, it's not vague, it's straight. So as you can see, there's bubble sort. You didn't say array bubble sort or sort array by bubble using bubble sort. You didn't use that. You instead used bubble sort with just two words. It's short and it's already telling the programmer what this function is doing. And there's already a parameter that says shuffled array. And once you look at that, you actually already know what that variable is referring to. It's referring to a variable that's an array that contains a shuffled items inside of it. So you don't need to really look at dig really deeply into the code to understand what it's doing. Already the code is telling you what to do by just having that concise naming convention in place. And clear code formatting, indentation, etc., and spaces as well. So one of the key features that you can add into your code is having new lines for each. This just makes the code less compact, and you can actually utilize these new lines so that they sort of separate or group together a form of context. So they group a form of context, making the code more readable to the user. So the user doesn't have to move his eyes very close, very hard. And as you can see, right on this part of the code, I tried to reduce that for loop into just one commonly used function. So this is actually a commonly used function, the array.from. If you're not familiar with it, you're probably still not using JavaScript that much. But if you've used JavaScript for more than a year or a year, you'll be familiar with what this function is actually doing. And you manage to achieve what a for loop, a 5-line of for loop is doing in just one line. And it's really easier to read because your eyes doesn't need to move up and down, back and forth. So, but spaghetti code isn't just with the code itself. It's also about the code structure, the overall structure of the code, the files, the names of the files, the folders, the names of the folders. How are the folders structured? Where do you put things? Where do you put this thing? If I need to use something, where do I find it? In which file do I find it? In which directory do I find this particular component? Those kind of things. Those things really affect the spaghettification of the code base as a whole really drastically. If your code base is not structured in a logical manner, then everyone will just have a hard time looking for things. So let's jump into a hands-on demonstration that I prepared for you for a short time. So I have here a React app that I created. So this is the app, and it's the only thing that it's doing it is showing you this list of to-dos, and then you can drag and drop the to-dos to reorder them. So we will try to refactor this in a way that makes it more readable and more concise and easier to manage. So we will focus on just one app, one file, which is the app.js, because this is not really a very big project. And this whole code base has actually been written really well. Um, it's been written in a readable manner, but there are still some things that we can enhance, and we'll try to look for those, and we'll try to separate things. So first is the most obvious ones are probably this. Oh, and by the way, I forgot to mention that this is using React. So this was instantiated with Create React app, and it's also using style components for the components. So let's try to extract all of these components into a separate file. Let's create here a components, and let's create a new file called presentational. And let's actually create a new folder. They're called these file components. And then I'm going to just um, move this we can move this into its own file because there's only three of them. So let's actually try and do that. I'm just naming it to do components because we're using it for the to-dos. And then we'll just try to export it out. And my editor is integrated with ESLint. So as you can see, it's telling me these errors here that you'll have to fix. So that's the very, very good use of ESLint. Then we just have to move this in here, and then we save that. And then now we need to import that file into here. So we forgot to move this part. Then we also need the margin on the top variable. It's more of a constant. Some people have this naming convention with constants where they do things like this. So you could also impose that into your conventions. But I like to keep things in this manner, in camel case. So now, if we try and save this, we see that it will compile, and then it should work exactly the same way. But now the codes is basically more structured so that when a newbie comes in and he needs to look for a particular component, he knows to go into the components directory, and it may be presentational. There's this convention with React where it's called presentational or container. So in this case, this is a presentational and a styled component, and he'll be able to find whatever it is that he's looking for in this particular file. So it conveys intentions, it conveys a message. And then the next thing that we can do here is to minimize these functions because as you can see, there's some redundancies here. So this on drag update and I believe the on drag start as well, they're doing almost the exact same thing except they're dealing with different variables. So we can actually extract the functionality and have that into a separate function that accepts some variables and then just computes based off that variables. So let's say compute, but before that, let's actually rename this one. This one's called custom placeholder. I think it should be called um, ghost placeholder props instead because it's actually being passed in here as a property and it's actually being used as a props for the placeholder component. So let's say ghost placeholder props. Then let's just do set and then I'll just rename these into that and then change these ones at the bottom right here into the new name. So now the name is expressing what the use case is for that function, or rather for that variable. The variable name itself is telling you that this is how to use me. This is how I am being used in this function or in this particular file. So let's proceed to moving this functionality into a separate function of its own. Let's call this compute those placeholder props. And then I'm just gonna go on ahead, and so the difference here is that this guy is using the source while the other guy is using the the destination. So that's the main difference. But other than that, it's pretty much the same throughout. So I can just grab this part, extract that, move it into this here, and then just accept it. So I could also even put this into that, because also that's also redundant in this case. So let's accept the index, and let's accept also the readable ID. So where it's being used source index, I'm just going to replace it with index instead. And then in this case, I am just going to remove this, and I am going to call this function right here on this callback, and just provide the index, which is source.index, and then the readable ID. And then of course, again, coding standards, as you can see, ESLint is not allowing me to violate the rules. It's telling me, hey, there's something missing on your code. You need to correct that. So that's how ESLint is very used. And then, so I just need to put here the this variable, and I may need to put in the another part here, which, all right, I don't need this. And then this is also telling me that there is something wrong with the code that I need to fix. So I need to provide in the state.tasks. And then I need to use this function on the other function here. So I'm just going to put it here and provide again that the index, which is the destination.index, and the variable ID, which is coming from the event as well. So I'm just going to remove these parts now, and okay, everything else seems to be good. And if you're wondering what this is just the ordering of imports. So it's telling me that I should order the imports alphabetical manner, but that's fine because this will be automatically fixed. It doesn't really affect the code. I'm just going to save this now. It recompiles, and I'm going to refresh this. And as you can see, it works the same way without any errors. So that's refactoring for the sake of readability. And if you have a very spaghettified code base, you might find yourself needing to do this more often than necessary, and in a longer span. Because in this case, it's a very short code base, so it's easier to manage and easier to rewrite and refactor. So that's it for this example. By the way, I'm going to leave you with the GitHub repository in case you're wondering, in case you want to see it or want to play with it, and you can do whatever you want with it. So, is clean code actually subjective? So I sort of had this, I think, discussion with some people on a particular page on Facebook, where we were talking about spaghetti code, and one of them just told me that spaghetti code is subjective. And yes, that's actually correct. Spaghetti code is indeed subjective, but the thing is, asking that, saying that spaghetti code is subjective is not really that the concern here. Is spaghetti code objective is not the question you should be asking, but rather the question is, to whom is it subjective to? And the answer to that is the company. The company must have an identity. The company must have an opinion, the team itself. That's why you need a team lead, a manager, so that this manager will enforce that identity, this opinion on the team members, and the team members will uh, do their job uh, according to that opinion, to that identity of the company. It must have a subjective preference, the company itself, not the individual developers, but the company itself. It's the company who decides what is clean code and what is not a clean code. It is a company that decides when a code is clean or not, or spaghetti or not, when a particular code is acceptable or not. It's the company that decides that. And most of the time, the companies that fail, that I've seen actually fail a project because of this problem, is because that they didn't have an opinion, they didn't have an identity. Often they would say they're neutral, like they don't care how you do it, just as long as you do it. But the problem with that is if you say that to four developers or five developers, each and every one of those developers will have their subjective preference of what a clean code is. So someone might be looking at this and then saying that, hey, this looks elegant to me, this looks beautiful, this is a clean code for me, right? And he might be writing his codes like this throughout the code base. And now you have what? How much percent of the code base is now um, at spaghettified just because of that lack of identity, just because of that lack of opinion. You must have an opinion, you must have an identity, and you must enforce that identity through all of the developers working on the project. So a spaghetti code a spaghetti code is really a software written in a way that doesn't follow predefined or known structure or formatting. So a spaghetti code is not necessarily unstructured. So people say spaghetti code is unstructured, unordered. Well, it's not necessarily unordered or unstructured, because even the most spaghetti code that I've seen in my career, it actually has a little bit of structure in it. It still follows a structure. It still follows a formatting. However, the formatting and the structure is, number one, unclear, vague, and it's not concise. Or number two, it's also inconsistent. Like you'll see a folder called leads, and then you'll see a folder called life helpers, and then you'll see another folder called libraries again. Yeah, it's like some things are just being repeated throughout the code base, and people are just making files all over the code base without putting them to the right folder. The format is inconsistent, and again, this is because of the lack of identity. The managers, the team leads, has to create these coding standards and has to enforce these coding standards to everyone in the team, and has to make sure that everyone in the team is following these coding standards. Um, follow the format Follow a format that is concise and consistent. That is the key to solving your spaghetti code problem or preventing it from even happening. I think a very perfect uh, environment would be an environment where you compare two people's codes against each other, and when you compare them, you could barely make any differences. You could barely see any differences. It would appear that these two code bases was written or were written by just one person, and that's because they're following a concise and consistent uh, coding standards, formatting that has been imposed or enforced by the company and the team leads or the managers themselves via their opinions about the matter. They should have sides, they should take sides, and they should enforce their opinions. So let's do a quick recap of what we just went through this presentation. First, we described what the spaghetti code problem is, and then we described what the nature of the spaghetti code problem is, and we sort of compared it with uh, cancer. And again, spaghetti code problem is not something that you encounter right now while you're probably just making the app in the past 4 or 6 months, but it's something that you will encounter as your app continually grows in the next few years. And we also described the symptoms of the problem, and we also talked about some of the things that you can put under that you can do to put the problem under control. And again, you need to also research and you need to decide on what your convention should be. There are companies out there like Airbnb who actually release their own coding standards, and you can follow those coding standards. Me personally, when I'm starting a personal project, I only follow my own coding standards. That's why if you look at this code base right here, it has its the bubble config, it has an ESLint RC with predefined rules that I myself continually upgrade and change. So you can create your own or you can follow somebody else's lead. It really depends on you. And then we also showed a hands-on example of what a spaghetti code versus a clean code would look like. And we also demonstrated a cleaning a code base, very tiny code base, and sort of cleaning it to make it more tidier. So that's it. Thank you for watching, John. I think John is
Hi
missing.
guys. Hi. Sorry about that. I'm having technical difficulties. Could you try and speak up, April?
Hello.
Okay, there you go. Okay, we're all set. That's really an interesting topic that we've talked about. I didn't realize that you can't really remove that you can entirely remove spaghetti codes. I didn't realize that it's not possible at all. That's good. So are you ready for questions, April?
Yeah, sure. Bring them on.
Okay. I'm gonna choose one for you, so it wouldn't be that much of a hassle in your part. Huh. Okay. So one question is that, what do you think about using TypeScript for better writing better codes? TypeScript is like jam packing JavaScript, right? For big applications.
Yeah. So TypeScript, for those who doesn't know, just for information, is a superset of JavaScript. It's basically JavaScript, but with some type preference in it, like objects, numbers, are those types are being enforced into the code base. And yes, that's actually a very good thing to do as well. So TypeScript is something that's becoming more popular because it allows more developers to write cleaner and better code that are easier to understand and easier to use by other developers as well. So yes, I would say go for that.
That's really good. That's really good. I think one of the questions also is, what are the tips that you would give out to someone who would like to start doing React development? Because that's a thing now, right? That's a big thing now, and everybody's like jumping in. I'm gonna learn it in Udemy. I'm gonna learn it to Coursera or whatever. So what tip would you give someone coming from someone that's been doing React now for quite some time? What tip would you give them to better learn React other outside the using online courses and all that? What? Yeah, that makes sense.
Well, I think the tip that I would give them is the thing that I myself has done. It's that to be self-reliant. Don't rely on someone else to teach you. Don't rely on a Udemy course. Don't rely on school, your professors to teach you how to code. So me personally, what I did is I always do self-study. Even until now, I still self-study quite a lot actually. So just write bunch of
Yeah.
codes like almost every day of your life. Don't even skip a day when you're not writing code, even just for 1 or 2 hours and then research, continually Google stuff. As time passes by, you'll find that you're actually becoming better and better. And the way you search is actually becoming faster and faster as well and becoming more and more efficient. So it's improving not just your coding skills, but also your research skills because part of being a
Correct.
software engineer is not just writing code, but also mostly researching for things.
Yeah, sorry, I saw a comment. It was from James Fowler. I saw it earlier. I just read through it again. He said that if ever he's the next speaker, he would call it lasagna codes. I think it's not much different. It's a bit
Well, I think
funny.
the reason why they called it spaghetti code is because if you look at spaghetti, it actually doesn't follow that
Yeah,
much of an order, right? It's like
yeah.
just goes around whatever ways they want. Unlike lasagna, I think lasagna still follows an order from top to bottom.
And one other interesting that you said earlier in the presentation is that um it's different to do coding to write codes, and it's entirely different to read codes. So
Yes.
for beginners specifically, what are the tips that you can give them, especially if they be handling a project that's not new, an existing project that they would like to redo in another language or any of that stuff. What are the tips that you would give them? You know, any tips that could help them read codes better, if that
Yeah.
makes sense. Yeah.
Yeah. So to read code better, unfortunately, I don't think I can give any tips that would allow you to read code better. And I don't think that you can actually read better in a way because fundamentally your reading is limited by your biology, your eyes, your movements. So if you actually study the sort of physiology of reading, your eyes, when you're reading, is actually jumping from one word to another. It's only able to do that. And that's the only way when you can read and at the same time absorb what you are reading. When you are doing fast reading, that is what other people go. But by the way, reading can only go as fast as like 200 to 400 words per minute. And that's the fastest that
Wow.
you can give while still maintaining speed. And the more you try to read faster, the more you sacrifice comprehension. So you could only really choose between the two. Do you want to read fast or do you want to understand what you're reading? If you try to read fast, comprehension drops down drastically. If you try to read to understand what you're reading, then reading speed drops down drastically as well. So I think the best way is to achieve a certain balance between these two. And part of that is part of the responsibility falls onto the writer themselves. The writer themselves should write the code in a way that makes it readable for the readers, regardless of any level. And actually, just to make like a quick quote, one of the things that I actually found when I'm doing all of these things, when I'm doing tech talks, I went to Pampanga to do tech talks. I talked to a lot of developers, engineers who are more experienced, who are more skilled than I am. And one of the common thing that I so, among them is this characteristic. They have somehow the ability to write code in a way that even an entry level can actually understand and read. So that's like a very good skill to have. And I think that's the only thing that really determines if a software engineer is an entry level or a senior developer, because a senior developer would care more about readability of the project than having to finish this task in like less than an hour.
That's a good answer. So basically, the problem or the tip is not really for those who's trying to read the code and versus those. It's not a matter of yeah. It's not a matter of those who would read the code, but it's a matter of those who coded it before and making it clean, readable and usable in a way.
Right, that's
Yeah,
right. Because even if you try to read a like a spaghetti code base, even the most senior software engineer you'll find would throw that code base away and say, "Take that away from my face,"
yeah, yeah,
because he
and they
wouldn't like to look at it.
yeah might as well redo it. The usual
Yeah,
response they'd be redoing it from scratch. Oh, there you go. That's a good question from Jay Tan. What's your opinion about code shaming?
code shaming. I don't think code shaming exists. It's most likely something that has to do with mindset. Again, going back um to my presentation, I have one slide there that says, "Don't compete with your teammates." Writing clean code is not like a competition. It's not a competition. Nothing's a competition. It's not a competition of who can write the cleanest code. It's not about that. It's not about who can do that more tasks in the more in the fastest way. It's not about those things. It's more of a team effort than it is an effort of just one guy. So if you're in an environment where people are shaming you for the codes you write, then maybe you're in a wrong environment. That environment might be encouraging competition, and that kind of environment is it's basically hard to live in because it's encouraging competition, and sooner or later, people who are under competed will leave. Instead, what people should do is they should encourage improvement. So instead of saying a code shaming, maybe I don't know how that code shaming happened. Maybe someone told him, "Hey, your code is really ugly. Like, why does it look like that?" So instead of saying that, maybe what you should do is say, hey, we have our coding standards. What you should do is read the coding standards and code according to the coding standards. That's why we have pull requests because it actually acts as a way to verify that this developer is not just putting spaghettified code into the code base, but rather it's putting code that conforms to the standard into the code base.
That's really interesting, April. So basically, what you're saying is that uh, it really depends on the perspective of the developer if there's such a thing as code shaming, because you can also interpret it as their own way to do it, right?
Right.
There's really no standard. There's a standard within a company or within an agency or something, but there's not really a universal standard. So it's really
Yes,
up to you
that's
and how
right.
you do it. That's a fresh new perspective. I think it's best for the next event that we might be doing uh like some kind of like debating thing in a way. Yeah, that would really be interesting. But yeah, I think that's most of which for our topic for today. Do you have like any other thing that you'd like to talk about, April, before we end this Facebook Live?
Well, firstly, thank you for inviting me in this event and
Yes,
for giving me an opportunity to share this knowledge that I have earned throughout the years of experience. And thank you for everyone. I hope you guys learned a thing or two from this presentation to maybe write a better code next time or start researching on how to write your codes in a more in a more clean way. And again, it's not about who can write the cleanest code. It's about a collaboration because one of the thing is that you could actually go back. One of the things that I've experienced in the past is that you're working on multiple projects. So you have this one project and then you move to another project and then you're focused there, say on project B, you're focused on project B for a year, and then you came back to project A and then you forgot the whole code base and you don't remember the whole thing now. So now you have to relearn. So the
yeah,
question then is how long will it take you to relearn that? So it's not just about other people, it's also about yourself.
correct.
So
Yeah,
it's like
100%.
I
I
think I
agree
call it
with you on that.
yeah, personally I call it writing codes with empathy.
That's a
Yeah,
good
like
thing.
it's an empathy to the reader. Like man,
Yep.
I'm gonna make your life hell by writing this code the ugliest possible way, or I'm gonna make your life heaven by writing a clean code for you.
Yeah, that's why companies now or hiring managers that I work with is really once developers that writes clean codes and apparently most of the devs that we have here does write clean codes. That's why we're like the go-to talent when it comes to developers such as April. I think April is a testament to that. But yeah, aside from thanking you, April, I'd like to thank our viewers who logged in or logged out or who's still working but tried to squeeze us in. Really do appreciate it. So this is for really for the viewers itself. Or yeah, I'm not sure if you can join April, but I hope you can. So basically, we have a survey that we posted in the comment section. So in the survey, you just have to fill it up real quick. And good thing about this one is that you have the possibility to win 5,000 pesos. We're gonna choose someone randomly, 5,000 pesos cash, and we're gonna send it over to you. But you need to answer the survey as detailed as you can. That's about it. And we're gonna do the picking like around the first week of March. So I'm not sure if you can join in April, but you can try to squeeze it in. You might win 5K, and you just can't pick 5K anywhere. Anyway, so
Yep.
that's really good. Um, okay, I think that's most of it for our time for today. We hope to have you back again, April, with a topic that you'd like to piggyback on that one, or you can join the thing that we're planning, which is like a debate type thing of developers or what their point of views are in specific subjects. But yeah, thank
Nice,
you everyone
interesting.
for your time. Yeah, it will be, especially if you're there. Yeah, thank you so much everyone for your time. Really do appreciate it. Happy Friday and enjoy your weekend. Thank you guys.